Basicity of Amines. Myself, Dr. Digna Varghese. Now let's start on the basicity of amines. Here you can see ammonia, primary amine, secondary amine, and tertiary amine. One of the hydrogen atom is replaced from the ammonia molecule by an alkyl or aryl group, that is primary amine. Two of the hydrogen atoms are replaced by alkyl or aryl substituents, that is secondary amine. If all the three hydrogen atoms in ammonia molecule are replaced by the alkyl or aryl substituents, that is known as tertiary amines. That all we know. So all the three kinds of amines like ammonia. In ammonia we know there are two lone pairs of electrons. In the same way as in primary amines, there is one lone pair, and in the case of secondary amine, there is also one lone pair, and in the case of tertiary amine, there is also one lone pair of electrons. So, all the three amines, like ammonia, contains one lone pair of electrons on the nitrogen atom. Hence, they have a tendency to donate electrons to an electron deficient species and thereby act as bases. We know uh, bases are those species which have a tendency to donate electrons to an electron deficient species. Consider the following equilibrium for a primary amine in water. Here you can see an equilibrium of primary amine reacts with water to give RNH3 plus OH minus. The water can be split like this: H plus or ionizes, water molecule ionizes like this, H plus and OH minus. So here H plus is the positive part. We know primary amine is a base in which the nitrogen atom contains one pair of lone pair of electrons, so it can attach to the hydrogen H plus ion and it can form RNH3 plus OH minus. So it's an equilibrium for a primary amine in water. The basicity constant, that is Kb, for the amine is given here as Kb is equal to concentration of RNH3 plus into concentration of OH minus divided by concentration of amine. Okay, so similar Kb expressions can be written for secondary and tertiary amines. If the greater the value of Kb, the stronger is the basic character. Kb is greater, stronger is the basic character. The lower the value of pKb, that is minus log 10 to the base of Kb, that is lower the value of pKb, stronger is the basic character of amine. Kb is higher value, stronger is the amine. Lower pKb value, that also means stronger is the amine. We can see a table, that is Kb and pKb values of ammonia and some amines. Here you can see ammonia molecules, that is the Kb value is 1.8 into 10 raised to minus 5. Its pKb value is 4.74. And for methanamine, its Kb value is 4.5 into 10 raised to minus 4. Its pKb value is 3.37. For dimethylamine, that is 5.4 into 10 raised to minus 4, and its pKb value is 3.13, and it's a tertiary amine. Its Kb value is 0.6 into 10 raised to minus 4. Its pKb value is 4.22. So all the Here you can see the aliphatic amines. The all types of aliphatic amines are stronger base than ammonia. Okay, here you can see its Kb value is higher when compared to ammonia's Kb value. We know higher the or greater the Kb value, greater will be the basicity of the amines. So, aliphatic amines are more basic than ammonia. And what about its pKb value? pKb is the negative logarithm to the base 10 of the Kb value. Okay, pKb is lower, stronger is the basic character of amine. pKb value is lower for all the three aliphatic amines when compared to ammonia. So, these aliphatic amines are more basic than ammonia from its Kb and pKb values. In the case of aromatic amines, here you can see aniline have the Kb value 4.2 into 10 raised to minus 10. Its pKb value is 9.38. And here you can see N-methyl aniline. Its Kb value is 5.0 into 10 raised to minus 10. And its pKb value is 9.30. And it is N-phenyl aniline, that is 7.1 into 10 raised to minus 14, 13.15 its pKb value, and it is benzyl phenylamine as benzylamine, and its Kb value is 2.0 into 10 raised to minus 5, and its pKb value is 4.70. So you can see here the Kb values and pKb values for all the aromatic amines. When compared to the ammonia, its value is about 4.74 pKb value. But in the case of amines, aromatic amines, that is weaker bases than ammonia. Okay, lower the pKb value, higher is its basicity of the amine. So, when compared to ammonia molecule, the basicity of the aromatic amines is weaker. That is, basicity of aromatic amine is lower when compared to ammonia. So, it's a weaker base than ammonia. This is due to the electron withdrawing nature of the aryl group and thereby decreases the electron density on the nitrogen atom. Okay. But in the case of aliphatic amines, the alkyl groups are electron releasing groups. So it can the tendency to donate electrons again to the nitrogen atom which has a lone pair of electrons. So this have a tendency to increase the electron density on the nitrogen atom. So it is more basic than the ammonia. In the case of ammonia, there is hydrogen atom only. Okay. So the electron withdrawing nature of the aromatic group attached to the ammonia molecules. So the basicity will decreases. But in the case of alkyl groups attached to the ammonia molecules, the hydrogen atom replaced in the case of ammonia molecules, the basicity increases due to the electron density on the nitrogen atom. Now we are going to discuss the relative basic strength of ammonia, methylamine, and aniline. Here, first, we are going to discuss the basic strength of ammonia. We know in ammonia, there are one lone pair of electrons present on nitrogen atom, which can coordinate to the electron deficient proton and forming ammonium ion. Okay. In ammonia molecule, there are one lone pair of electron present. So the nitrogen atom is electron denser. So it can act as a base by donating electrons to an electron deficient proton and forming ammonium ion. In the case of methylamine, here you can see the same lone pair present on the nitrogen atom as in the case of ammonia molecule, but the one of the hydrogen atom in ammonia molecule is replaced by methyl group here. So it is known as methylamine. It's a primary amine. And methylamine, methyl group is electron donating group. So it can donate electrons towards nitrogen. So the nitrogen becomes more electron denser when compared to ammonia molecule. So it can more easily coordinate to the electron deficient proton and forming methyl ammonium ion. In methylamine, the electron donating inductive effect, that is plus I effect of methyl group present, increases the electron availability on the nitrogen atom. So the methyl ammonium ion formed from the amine gets stabilized due to the dispersal of nitrogen positive charge by the plus I effect of the methyl group. So the plus I effect of the methyl group make the amine more basic than ammonia molecule. So methylamine is more basic than ammonia. Okay. In the case of aniline, a lone pair of electron present on the nitrogen atom which can coordinate to the H plus ion and forming anilinium ion. Okay. Here in the case of, as in the case of methylamine and ammonia molecule, aniline also having lone pair of on nitrogen atom which can act as a base by donating electrons to an electron deficient proton and forming anilinium ion. But in aniline there is plus R effect, plus R or plus M effect is present on the NH2 group attached directly to the benzene ring, makes the electron pair on the nitrogen atom less available for protonation when compared to ammonia and methylamine due to the electron withdrawing effect of the benzene ring and also due to the resonance effect, plus R or plus M effect of the benzene ring on the NH2 group in aniline. Here you can see the plus R or plus M effect of aniline. Here you can see the aniline and here an lone pair of electron present on the nitrogen atom which can donate electrons to the ring so that the electrons shifted towards this carbon and forming negative charge on this carbon, and this bond becomes a double bond and the nitrogen atom becomes electron deficient and forming a positive charge here. Due to the electron delocalization takes place again, and here the electron is shifted to this, and the electron move to this carbon and forming a bond here and negative charge on this carbon. Again, electron is delocalized here and forming to the next resonance hybrid with negative charge on this carbon and a bond formed here. Again, delocalize the electrons and forming to the next resonance hybrid, and you can see electrons on the nitrogen atom, and the bond is shifted to the next or the resonance structures from this to this by plus R or plus M effect of the ring. So here you can see a delocalization of the nitrogen lone pair over the aromatic ring. So it is less readily available for the protonation to the and forming aniline ion when compared to ammonia molecule and methyl amine. So the small positive charge on the nitrogen repels the proton here. So aniline and other aromatic amines are less basic than ammonia or aliphatic amines due to the plus M and plus R or plus R effect of the benzene ring. So the anilinium ion, that is C6H5NH3 plus, formed when aniline accepts a proton, has only two resonance structures. Here you can see one is here and the other one is here. Okay, so the anilinium ion is not as stabilized through resonance as aniline, which has 5 resonance structures. Okay, for this reason too, aniline has less proton acceptability and is less basic than ammonia or methylamine. So the relative basic strength of ammonia, methylamine and aniline varies the order as methylamine greater than ammonia and aniline. So the order of relative strength of basicity is methylamine greater than ammonia greater than aniline. So the most basic amine is compound is methylamine here, and the least one is aniline. Here we are going to discuss the basic character of amines. That means it can react with acids. So being basic in nature, all types of amines react with acids like hydrochloric acid, nitric acid, sulfuric acid, etc. to form soluble salts. So here the general representation of an amine reacts with hydrochloric acid and forming RNH3 plus Cl minus. Okay, RNH3 plus Cl minus. So methylamine reacts with HCl and forming CH3NH3 plus Cl minus. So in the same way as that of aniline reacts with HCl to form anilinium chloride. Okay, anilinium chloride. So primary amine reacts with HCl to form alkyl ammonium chloride. So methylamine reacts with HCl to form methyl ammonium chloride. Aniline reacts with HCl to form anilinium chloride. So, in the next case, the secondary amine reacts with sulfuric acid. It can react with HCl also. Secondary amine can react with sulfuric acid to form. All types of amines react with HCl, H2SO4, HNO3 like acids to form soluble salts. Here, a reaction between secondary amine and sulfuric acid to form dialkyl ammonium sulfate. Okay. Here you can see dimethylamine reacts with sulfuric acid to form dimethyl ammonium sulfate. Here you can see a tertiary amine reacts with nitric acid to form trialkyl ammonium nitrate. Likewise, trimethylamine reacts with nitric acid to form trimethyl ammonium nitrate. Okay, just an adduct form. Thank you for your attention.